Thank you for joining us on today's webinar, Does It Really Need to Be Calibrated? Requirements on Measurement Equipment in a Certified Quality Management System. When you joined, you were all placed on mute, so please use the chat function to ask any questions, and we'll be sure to leave time at the end to answer those. This webinar, as you might have just heard, is being recorded and will be available in the coming days. I'm going to introduce our speaker today. Our host today is Don McFarland, who is the Aerospace Technical Manager for NSF-ISR, the Management Systems Registration Division of NSF International. He has worked as a quality engineer, quality director, facility security officer, consultant, lead auditor, and auditing instructor in various aerospace, medical, and commercial goods manufacturing organizations. He presently works in the America's Aerospace Quality Standards Committee, IAQG. He resides in northern Utah. Don is accompanied by two other of our NSF-ISR business unit managers, Mr. Marty Willem, who's the business unit manager of our Quality Management System program, and Mr. Mike McRandall, who is the business unit manager of our aerospace program. And with that, I'll hand it off to you, Don.
Perfect. Thank you, Melissa. Welcome, everybody, to this next installment of our webinar series. As Melissa said, we're going to talk about calibration, one of everybody's favorite topics. So we're going to start off with a poll, as we've done in the past. Go ahead and fill out your options here. It says, I will drink from a gallon of milk when the container shows it expires today. Impossible because it's already dumped out. I just dump it down the drain when it's expired after I smell it and it's okay. Or dates are a sell by and it'll be all right. So go ahead and fill out that survey response. We'll give everybody just another couple seconds. And 5, 4, 3, 2, and 1. Excellent. Looks like nearly everybody responded. Wow, that's disgusting. So I'm one of those guys that doesn't touch the milk if it's showing on the expiration date is today. But it seems like a number of us will smell it and see if it's all right. That's interesting. We'll come back to that later. I'm going to circle back in a few. Next question says, I'll check the expiration dates of my medications before I take them. Always, sometimes, never. And medications have an expiration date? Question mark. Go ahead and fill that one out. Excellent. 5, 4, 3, 2, and 1. So overwhelmingly, our medications are something we're going to check. Now, the interesting thing that I found here is medication dates were enacted back in the 70s. Medication expiration dates, rather, were enacted back in the 70s. And according to a Harvard Medical Journal study, most medications are actually good. With a few exceptions, they're good for decades after the expiration date that's reported. Yet we know our milk is something that we're not necessarily going to drink once it goes sour, and it can absolutely go sour before that date. Something to keep in mind. We're going to circle back to that here in a little bit. So first off, here's the introduction. There's a foundation slide talking about the importance of metrology. And I couldn't find anybody to attribute anything in this realm to, so I gave you a quote from me. It says, a robust metrology program offers confidence in the tools that provide confidence in our products and processes. And you think about it, we expect our product to be good going out the door, and whether we're putting more emphasis on controlling our product through inspection, or we're putting emphasis in APQP or PPAP type activities, we've got some process controls in place, and we have metrology or calibrated verified instruments in place to ensure control over those processes. Those are the tools that are going to help us determine our success. So if we're unsuccessful there, we're probably going to have lesser success in shipping a good product. Now, with that said, we're going to talk, as we have in the past, about some of the requirements from the standard. I am going to deviate a little bit on how I approach that. We'll talk about some commentary things, and then we'll answer any questions that you might have. With regard to the questions, I would love to have you type those into the chat function, and we'll get to those as we get to the end. So first off, the standard questions. And the question we're all dying to know is, what needs to be calibrated? Now, when you see this clause, or excuse me, this section that's highlighted in orange, that's going to be a citation right out of the standard. And those that have joined us in the past know that anything that is this normal font is going to be an ISO 9001 requirement. If it's a bold italics font, it'll be an AS 9100 supplement to the 9001 requirements. And we're really going to slant towards those two standards, although these requirements are going to translate across a number of other schemes. Okay? So the requirement here is the organization shall determine and provide the resources needed to ensure valid and reliable results when monitoring and measuring is used to verify the conformity of products and services to requirements. So the organization gets to determine the resources needed to ensure that the product and processes are good. So in short, if we're going to use a tool for inspection, tests, or controlling our processes, it's something that's necessary or perhaps necessary to control our outputs. Therefore, we want to have those devices, those tools, calibrated or verified. Okay? How about customer-owned tools or customer-provided equipment? Who's responsible for that? I'm posting these sections in here. These come from the IAQG clarifications document. Those IAQG clarifications tell us, in this particular case, that it depends. If the gauges, or excuse me, with regard to the question, do I have to calibrate customer-supplied gauges? Do they have to be current, or would that waiver from our customer work? And the answer is it depends. If the gauges are common metrology devices like calipers, micrometers, etc., it's expected that we calibrate them or verify them. If the customer-supplied gauges are unique customer tooling and provides a waiver that the gauges don't require calibration, it's encouraged to utilize other methods as appropriate to ensure the accuracy of the measurements. The customer waiver stating the gauges don't need calibration should be included in or referenced on the paperwork returned to the customer. Ultimately, the purpose of this metrology section, this calibration section, if you will, is to ensure that we have confidence in our product, confidence in our services, and if we're not using good tools, if we're using tools that we don't have confidence in, how are we going to assure that those processes are effective? So when we do that calibration or verification effort, we need to ensure that the resources provided are suitable for the type of monitoring and measurement activities being undertaken, and maintain to ensure their continuing fitness for purpose. And the example I put up here is using the right tool for the job. It wouldn't be acceptable for us to use a tape measure for verifying a 10 thou tolerance. It wouldn't be acceptable for us to eyeball certain metrics on the tape measure when they're a tight tolerance like that. Also, a tape measure doesn't have the graduations, the lines that are printed on it that would be able to show a 10 thou increment. So a tool like that's probably not appropriate. And that's what this section of the standard's talking about, making sure that we're using a suitable tool for the specific type of monitoring and measurement activity being done. And then we're going to maintain them so that they're continuing to be good. Now, it doesn't say anything about doing an ANOVA or any kind of capability study or anything like that in here. This is the extent of what it's going to say regarding that. But it may be advantageous for your organization as a means of addressing risk to take this a little further and ensure that you have an understanding of the tool's capabilities, especially if it's not one of those standard tools. Okay. Section 7152, and I'm going to jump around a little bit, but I'll cover everything, I promise. 7152 says when measurement traceability is a requirement or is considered by the organization to be an essential part of providing confidence in the validity of the results, the equipment needs to be calibrated or verified or both. We're going to talk about what calibrated versus verified means here in a moment, but I wanted to highlight the first and more important thing here. We need a process. We need some methodology for controlling our measurement traceability activities. Now, is this always required? And the answer there would be no, when it's a requirement. So when would it be a requirement? I'm going to defer back to Section 4 of the standard that says our organizational context is going to determine that. If our customers are asking for precision, if our customers are asking for products that meet a certain criteria or dimensional characteristic, then we need confidence that the tooling used for that inspection or for that test or for the manufacturing activity is reading accurately, that it's capable, etc. So we're going to calibrate or verify or both to ensure that we're providing the right results. All right, calibration versus verification. Now, by the definition, calibration is different than what we've known calibration to be for all of our careers. We've always used calibration as this, encompassing bucket to include all verification, monitoring, measuring equipment, the metrology, whatever we want to call it. In reality, calibration is a verb that talks to adjusting precision or adjusting precisely for a particular function. So we calibrate, we adjust the tool to meet the requirement. Versus verification is confirming through the provision of objective evidence that specified requirements have been fulfilled. Now that requirement comes directly out of 9000, ISO 9000. That's where I'm getting these definitions, so I'm not going to contest any other versions of that. This is what the ISO community has told us. And verification is going to be the confirmation of the tool against the known standard versus calibration is adjusting it. Okay? With those definitions in mind, again, the standard requirement is we're going to calibrate or verify or both, because sometimes we do need to do both. We need to adjust offsets. We need to find a plane. We need to do that confirmation against a requirement, and then we make some adjustments for the environmental conditions that it's in, temperature, humidity, etc. Okay, in addition to that, we're going to do it at specified intervals. It doesn't prescribe timelines, and it also provides us the option of doing it prior to use against measurement standards traceable to international or national standards. And when no standards exist, the basis for that calibration or verification needs to be retained as documented information. So essentially, we're going to do it to the standards that have been derived from some national science institute, or NIST in our case, or whatever nationalistic equivalent there might be. Or if there's no standard that exists, we're going to come up with a method. We're going to define that method in documented information, and then we're going to have some evidence to show that that's been done. Now, with regard to the tool, we're going to need to identify the status. So it needs to be identified on the tool so that we can determine its status. And I'll talk more about that here in a moment. It says we also need to safeguard from adjustments, damage, or deterioration that would invalidate the calibration status and subsequent measurement results. Okay, so we're going to protect it, safeguard it, we're going to identify its status. That's about all it says here. Okay. Status identification can be done in a number of ways. Most commonly we see those labels, and we've all seen labels on those calibrated tools. Those labels are going to have a varying degree of format, varying degrees of content. Ultimately, that content is going to be based on what you, the organization, determine to be necessary. The ISO standards, the AS standard do not define what the label content needs to be, because as we've seen, the standards requirement is simply that we need to identify the status, or identified in order to determine the status. So whatever label you choose is going to be dependent upon your needs and expectations of your customers, your interested parties, etc. Okay? Ultimately, that label is going to help, or that status identifier is going to help us to ensure that our users of those tools know that it's a good tool, that it's conforming to the requirements, that it's capable, etc. It's been blessed as having the possibility of being good. Now, the editorial comment that I threw in here, and for those that I've audited with or audited at, you know that I've said this to you, do we really care about when the cow or the milk came out of the cow, or do we care about when it's supposed to go chunky? And pardon the graphic reference here, but the point is it necessary for us to have the date that it was done on the label? Is it necessary for us to have the information about who calibrated it on the label? And if we go back to, again, the standard requirement, it simply says identified in order to determine their status. So we're looking for some identifier on the tool that shows us ready or not. Okay. Now, my slides are a wee bit out of order, so I'll go to this one. Are there other ways to identify status? And I'm going to propose that there are, because in a lot of environments, manufacturing work environments, stickers just don't survive. And I've seen that on numerous occasions conducting audits or through my career, where those stickers have peeled off or the content of those stickers have disappeared because of the manufacturing chemicals or the handling methods, whatever it might be. So I've seen companies use a nail polish dot as an example on the tool itself. They'll just put a colored dot, and then they have a decoder ring hanging on the wall or in the procedure that folks know if it's got an orange dot, it's valid through the end of June. If it's got a green dot, it's valid through the end of December. Now, if I see this tool with an orange dot and I know it's July, that tool is expired. That tool is past its date. Okay? Are there other ways to do it? Absolutely. This thought process for that particular client came from the license plates. We all know we've got these little tax stickers that go in the corners. That provides a visual cue to the police, to whomever, to know whether or not that registration is still valid. And that really is the intent behind this identifier on the tool, is to tell the user, to tell those that are interested in the validity of that device, whether or not it's still good. Okay? Does that mean that it's perfect? Does that mean, or does that guarantee that it's good? And I think the answer is, we're all saying is no, and we'll talk more about that. Okay. The other thing that needs to be available is some way to link to the documentation. Typically that's done through a serial number. We've got maybe a mic 11, as you can see imprinted on this particular tool. So now I can go back to the certificate associated with this calibration effort, or the retained documented information, as the standard calls it, which demonstrates the traceability to NIST. Okay? So really those are the things that need to be there. The rest of it's going to be based on your organizational needs and your confidence in the process, etc. The other part that the standard talked about in item C was safeguarding from adjustments, damage, or deterioration. So examples here would be these tamper tapes or thread lockers, witness marks on screws, potentiometers, adjustment mechanisms, or whatever they might be. Because if we know that somebody's cracked into the case and possibly touched the quote-unquote guts of it, do we really have confidence that it's still reading correctly? And I threw this picture of the foodstuffs on the left because they all have this tamper-evident tape along the top, right? That film, that seal. Would you open a jar that didn't have that or where that was compromised and eat it? Would you drink from a bottle of soda or a bottle of water that had that perforated ring around the top? Would you drink if you saw that broken? I think we're all saying no. So we really shouldn't be using calibrated instruments or verified instruments if these tamper-evident marks or tamper-evident devices are compromised, because we truly don't know if the tool is still good, still valid. And we'll get to the questions towards the end of the presentation. Again, if you've got them, please go ahead and type those into the feedback section. We'll set aside some time towards the end of the presentation to talk about that. Okay. The next section of the slides is going to talk about the certificate, demonstrating the fitness for use. We need to have some objective evidence, something to show that the tool is acceptable for use, traceable to national or international standards. And if we go back to what the standard says here in this orange box, the organization shall retain appropriate documented information as evidence of the fitness for the purpose of monitoring and measurement resources. So the tool is valid, it's capable of performing in the range that it's operating in or that it's being used in. The other section here, or defined methods for calibration or verification. Again, we need to have documented information when we don't have a nationalistic standard, we don't have that international standard. We're going to have some documented information that demonstrates its fitness for purpose against the method that we came up with. Okay? So not only do we need records of quote-unquote calibration, we need records to show our method for calibration. Now, if it's against a national or international standard, typically that certificate is going to say per procedure 123, per NIST number or requirement number. It's going to show somehow what that requirement was. One of the things we wanted to talk about here is if we're outsourcing that within that certificate or on that certificate, we probably want to ensure that the certificate has some evidence to show that the provider is A2LA or accredited to perform the function. It may link to their company name, and then we go look at their accreditation profile and see that they're capable of doing that particular style of device or that particular instrument. I can tell you that I've been on audits where we pulled tools and pulled the certificates for those tools, and then we looked up the third-party provider for the calibration effort and found that they weren't accredited to perform the calibration of those particular devices. And the ISO and AS communities, believe it or not, that's not necessarily an issue as long as you as a company can accept the risk of it. In other schemes like TS or now IATF, it's called, that becomes a nonconformity. So why would we want to send our calibrated tools to or our verification efforts to one of those external providers that isn't necessarily demonstrating their capability of performing those calibration efforts? One of the other clarifications I wanted to throw in here from the most recent IAQG clarifications talks to the certificate itself and the requirement or the perceived requirement of having a link to the measurement standards and the NIST numbers or the traceability information on the certificate. And the IAQG has said there is no 9100 series requirement that the National Measurement Standards traceability information is recorded on the calibration certificate. It's expected that your organization selects calibration sources that meet the requirements, and that these sources are monitored and according to your supplier quality requirements or your external provider requirements. There may also be some regulatory requirements that you have to adhere to, some National Aviation Authority requirements, as it says down here. But overall, there isn't a direct requirement that says the certificate from your provider, your external provider, needs to link to the NIST number or the traceability number for NIST. Now with that, we do need some evidence to show what standards were used on the certificate. So the serial numbers, but as far as linking to the NIST number for the serial numbers that were utilized, that can be done in other records. Hopefully that makes sense. The next slide talks about out of tolerance events. So if we have tools and we get them calibrated or verified or both, that specified interval, we're going to have either a passing result or a failing result. If it's passed, everything is good. We've got those retained, documented information articles that demonstrate fitness for purpose. If it's failed, we want to make sure that we've analyzed the product that may potentially be at risk for the failed calibration effort. Okay, so if my tool was bad, my tool wasn't reading 0 properly, or it wasn't reading a particular voltage properly, it's really not capable of confirming measurement results, perhaps. What we're looking for here from the standard says the organization shall determine if the validity of previous measurement results has been adversely affected when measuring equipment is found to be unfit for its intended purpose, and shall shall take appropriate action as necessary. So we're going to look for the as received failed, meaning as received at that external provider, it was failed, and as returned, repaired and in calibration. So it's been adjusted back to a good state, but as they received it, it wasn't reading properly. Now if I send a caliper out and it's been adjusted by a 1,000th of an inch, and I'm measuring stuff that has maybe 30,000th tolerance, there's probably not a significant risk to my product. And that's where it gives us a little bit of leeway and says, as appropriate. We need to be able to demonstrate that we've done that review, that we've done some due diligence to ensure that that out of tolerance tool didn't impact product, and that action was taken against that tool and against the product that was impacted. So it's not just quarantining that potentially bad tool, it's doing some analysis against the product, the jobs, the historical devices that were measured by that tool. We already have improvement tools that are capable of this, so we don't necessarily need to reinvent that wheel, but for some companies they choose to have an out of tolerance form, or an out of tolerance and a significant out of tolerance form based on the risks to their business or their regulatory statutory requirements. That's great. For other more simplistic organizations, they can utilize that nonconformance or corrective action tool to take that appropriate containment action against product that may be impacted, or to confirm that no product was impacted, and then against the cause of the tool having the issue, and take action to ensure that it doesn't occur again. We've got the tools, we've got the vehicles to execute that type of an improvement effort. Rather than reinventing those, we can certainly just utilize those tools, or if our business wants, we can choose to create our own tools for it. Either way, if we find a tool that's out when it's calibrated, whether it's returned in calibration or not, we do need to go back and look at some history to see if the product was impacted or not. Now the standard tells us, or talks about a register, and the requirement is, again, bold italics font, so it's an AS requirement. It says the organization shall maintain a register of the monitoring and measuring equipment. The register shall include the equipment type, unique identification, location, and the calibration or verification method, frequency, and acceptance criteria. If we remember back to the the AS9100C requirements, this is a slightly different wording than what was in the previous version. In clarification, the IAQG has said, yep, we know it changed. We didn't mean for it to change the requirement. So the 9100 series clause was not intended to force an organization to have the register specifically include the equipment type, unique identification, location, and calibration or verification method, frequency, and acceptance criteria. The organization is required to have this information for the equipment listed, but not specifically within the register as the standard tends to imply or state. So as long as we have a register that's identifying tool dates, because we're going to use that information to help control our recall activity, we can still have linkage off to the methodology that we're going to use for calibration, the storage location for those tools, et cetera, et cetera. As for the frequency required, the standard, again, doesn't tell us shall be annually, shall be semi-annually. It says at specified intervals. So it's going to be a business decision for each company, and we're going to consider the complexity of our product, the tolerances that we're measuring, the storage conditions for our product, the redundancy of the inspections that are being performed, the frequency of that tool being utilized, maybe the potentials for failure, measurement error, stuff like that. We're going to consider all of the risks associated with the tool, and we're going to determine how often that tool needs to be reconfirmed or reaffirmed as being good, as being valid. Now, if I'm using a tape measure versus a micrometer, we know that there's much more precision in a micrometer. We know that there are many more finite moving parts that are directly impacted by some environmental conditions that a more robust, more resilient tape measure won't be impacted by. I'm not discussing here the use of the different tools because they are very different, but the frequency of a, say, tape measure being confirmed or reaffirmed if necessary by your organization isn't going to be the same as a micrometer that's used on a daily basis. Okay? I've been to organizations where they require their tape measures to be reaffirmed or verified on a daily basis against a standard like this, where they're putting the tab against this surface and they're measuring to the 4-inch and the 6-inch mark to confirm that that line shows up in there, just so they don't have any breakage of the rivets here. All right? That's a risk to their business, and they wanted to have that verify before use type of a tool. And then I've been to businesses where, you know, a micrometer gets used once in a year, and they had a 3-year cycle on the micrometer. It's, again, up to you as long as you can demonstrate the tool is fit for the purpose it's being used for, and that it's capable of performing that measurement, and that it's still in good status, and when it's not in good status, the product impact is analyzed. Some food for thought, and this one's always been interesting to me. Some of these tools are a little more complicated to read. Analog micrometers, as an example, there's a lot of lines that are built into that barrel that aren't necessarily intuitive to read, that aren't easy for you to determine the resolution, or excuse me, the value, the measurement. So we need to not only have good tools, but we need to have confidence and competence in reading those tools, and that's going to point back to the 7.2 competence program, right? As well as if I'm measuring a tool or measuring a product against a tool that requires some visual acuity like this, I probably want to look at the environmental conditions, the lighting, to make sure that I'm able to see that stuff. I also want to be able to ensure that the folks that are doing it have the visual acuity. They have the eyesight to be capable of seeing some of those really small lines. If my employee is colorblind to a certain color, maybe a tape measure that's of that color is not advantageous for us, or the lines that are painted onto the tool should be changed. I know I struggle, I have a disease with my right eye, and I struggle to see red tints. So having red graduations on a tool don't work for me, and I have to come up with something else or I won't be able to see it. Something to keep in mind. So speaking of those suitable environmental conditions, I mentioned the lighting already. It's going to really depend upon the tooling and the materials that are measured and the tolerances. Really what the standard says is we got to ensure that calibration or verification of monitoring and measurement equipment carried out under suitable environmental conditions. And then it links back to section 7.1.4, which is that work environment. So there's a tie between the two for sure. Within 7.1.5, it's speaking more of the calibration or the verification lab, if you will, where that effort's being done. And while a mechanical tool may not necessarily be impacted by humidity or light, some other tools absolutely could be. When we think about our NDT processes, the UV light or the white light environment is going to be directly impactful to the effectiveness of our NDT operations, non-destructive testing operations. So as I'm calibrating those types of instruments, or I'm verifying those types of instruments, we need to be cautious of the ambient light. Likewise, if I'm doing some verification efforts with in the sound arena, ambient noise or vibrations may be impactful to the calibration or verification effort. In some cases, that material coefficient of thermal expansion is going to play a role, depending on the type of tool, the type of measurements, the tolerances. So we need to ensure that we understand the capability of those tools, maybe as they're being measuring a heated part that's coming out of a HIP furnace or a heat treat furnace, right? For electronics equipment, humidity may be impactful. For our tanks, our chemical plating tanks, for our stripping or cleaning type tanks, we're going to use a ton of chemicals. And those chemicals, the concentrations of those chemicals and possibly even the loading could be impacted by the humidity. So we need to be cautious of how those are stored. We get the point with this. The last one I wanted to bring up is contamination. If I'm opening the barrel of a micrometer to do an adjustment and I have an environment that's riddled with FOD or littered with FOD, foreign object debris, and I close that barrel back up, is there a potential that FOD has been introduced into the tool such that it can cause some grinding or binding as we're trying to use that tool? Is it necessary for us to use certain concentrations of alcohol or isopropyl alcohol as we're cleaning those tools? And are we needing to use certain PPE to ensure that we're protecting not just ourselves but the tools? When defined as a requirement or for product or for process control, we need to calibrate or verify the monitoring method, meaning if my environmental or my calibration lab is requiring a 68 to 72 degree and 30 to 60% humidity, now whatever tool I'm using to monitor that environment so that I have confidence in the outputs of that really need to be calibrated. So there's a hygrometer, a temperature and humidity gauge hanging on the wall. We need to have that gauge calibrated so that it's able to demonstrate that expected requirement has been met. If we're not defining a tolerance, we're not defining a value that it has to operate in, calibration may not be required or verification efforts may not be required. But if we're defining an environmental condition or we're defining a requirement associated with a process, we really need to have those tools that are being used to monitor that calibrated or verified. Info derived from the equipment manufacturer's manual may help us to understand what truly does require calibration or verification. The manual is going to tell us it only can operate in a certain temperature range or a humidity range. Therefore, we need to ensure that we're controlling the environment such that it's providing valid results within that range. Something to be cautious about. So that's the extent of what the standard says regarding the calibration side of it. Now we'll move into some commentary items regarding different types of tools. Again, if you have any questions surrounding what we've discussed, and I see a bunch that have been populated already, please feel free to type those into the comment box. We'll try to address them all today. If not, we'll take the conversation offline and come chat with you personally. The next one is regarding verify before use. And this is something we see all the time as auditors, and I'm sure you've seen it in your careers. Now, with a verify before use, what we're doing is we're calibrating or verifying this master, this torque control type unit, right? Or maybe the micrometer that's being used to verify these pin gauges. And then we're going to confirm the pin gauge each time, or we're going to confirm that torque is accurate because it's being adjusted or set each time. We're going to confirm that it's reading good. Perfectly fine. We want to make sure we're using the right master, or we're using the right gauge associated with that, using maybe a 10-to-1 ratio or whatever number you come up with as a company. But that's going to help us to reduce the impact of product that's out of tolerance as a result of doing that confirmation. So we verify it every day, we verify it every job. So now I only have risk of that job. I have risk of that day's work instead of everything that that pin has ever been used in. Again, it's a risk-based thinking type approach. If I've got a pin gauge that's used on every product, there's wear and tear on a pin gauge. Maybe it gets dropped and it starts to mushroom on the end. We want to be cautious about using those for too long. Likewise, pin gauges are pretty darn expensive to calibrate a set or verify a set. Sometimes it's cheaper just to buy a whole new set than to send it out for verification. So using a micrometer and having the folks using it, using the different pins, confirm them against the micrometer on a daily basis or a per shift basis or whatever it might be, is the more economical way of approaching it. And that's great as long as we have the documented information requirements still met. We still need to show that tool was tied to this tool that's then tied to a certificate or some documented information about fitness for purpose. I see a lot of companies that do calibration of the tool and then they reconfirm it periodically anyways. So that means my torque wrench is calibrated or verified, my torque meter, my torque analyzer is calibrated or verified, and then I'm still on a daily basis or per shift basis, whatever it might be, going to plug this into here and make sure that it's reading the correct inch pounds. That's great because that's going to help us to reduce the risk even further by limiting the amount of product exposure for one of those out of tolerance events. The bonus there is, in addition to the smaller population at risk, there's really not a whole lot of documented information needed for that verify before use effort, because it really becomes more of a confirmation, an ongoing confirmation versus a calibration or verification effort. The next slide talks about titration and chemistry. A lot of our wet processes are going to use chemicals for the purpose of titrating tests and demonstrating that it's still at the right pH level or the right concentration level or whatever. The control solutions, we need to make sure that those are maintained within the shelf life, because a lot of those are going to have an expiration date, and that they're stored in the correct environmental conditions. It'd be no different than leaving your milk out on the counter for a month. It's obviously not going to last if it's supposed to be in the refrigerator. If I have a buffer solution that's supposed to remain in a freezer and I leave it out or in the wrong temperature range, then it probably isn't going to be as effective as it needs to be for performing these test methods. Okay? The methods need to be defined for performing these tests, no different than anything else, and documented information of the results and the actions taken, like batch changes or batch changes and adjustments, would be necessary there. That's going to be more on the process control side. Really, for the calibration efforts, it's going to be using solutions to calibrate pH meters or something like that. I use the term measurement systems here to represent what prompts this, I should say, is I have a height stand sitting on a granite block. We calibrate the height stand or maybe the dial indicator that's attached to that. Does it make sense when I'm putting that product on a granite block that has a sticker on the side that says for reference only? Because now I'm creating a plane that may be not quite at the same level as what this is sitting on, and it could definitely present some risk to the product or to the measurement method. Likewise, if I'm going to support something on a 1, 2, 3 block, or I'm going to use that 1, 2, 3 block to create a plane and measure, negative surface deflection or something like that, maybe we need to think about the calibration or verification of those 1, 2, 3 blocks. It's going to depend upon your situation. It's going to depend on the measurements that you're performing, but it's certainly something to consider. If I'm using that granite for anything other than a table, I probably want to think about having that surface confirmed so that I know if I put this height stand on it and read something off of it, it really is X number of inches from the bottom of the stand to the top of the part or to the top of the feature. Okay? Now, this is another one of those fun, controversial topics. For reference only, everybody loves to use for reference only or that type of a system for tools and say, you can't look at this because it's for reference only. Now, I'm going to tell you the standard doesn't talk about for reference only tools. The standard says, shall demonstrate fitness for purpose and retain documented information as such. We've been through what the standard says. So if you want to define a for reference only type of tool and a for reference only type of system, now you got to have a process that covers both those calibrated and reference only type tools, and when one would be appropriate, when one wouldn't be appropriate. Typically, calibrated tools are going to be, well, I shouldn't say typically, calibrated or verified tools are going to be used when we're confirming product, whether it's in process, final, or a test operation. If we've got a prescribed inspection, prescribed test, we're going to need to demonstrate that the activity was performed using tools that are calibrated or verified, because we need to have confidence in the results. If I'm using a for reference only tool that hasn't been through a calibration effort, it's no different than using an uncalibrated tool for that. If we don't have confidence in the results, we really shouldn't be measuring our product. We shouldn't be measuring our processes against those tools. It's not, let's see here, it presents risk for use in controlled activity. And what I mean by that is, if I have a set of calipers that are for reference only, and I've got one set of calipers for the entire area that are calibrated, and multiple people need a set of calipers, there's a pretty significant risk that those out of calibration or uncalibrated or reference only tools are going to make their way to an inspection bench. And if I'm using that inspection as a prescribed step or prescribed inspection, and there's a chance that those for reference only or uncalibrated devices are going to be used, that presents a problem. Okay? Ultimately, again, the standard is looking to have confidence in our measuring results by controlling the quality of the tools, demonstrating that they're fit for use. So having the process in place to ensure that you're only using those tools for measurement, for inspections, for test is important. Now, I'm not saying, certainly not saying we can't have tools that are there for setups or for, an engineer wants to tinker at his bench. That's perfectly fine. But we need to understand, and we need to have a system associated with what these can and can't be used for, and how we control those so that they don't get mixed into that calibrated population. Okay? Now with regard to the label, as an auditor, I don't really care what the labels say. That's going to be dependent on what you buy, what your system says. What matters is you have a process associated with the effort, and if your label, or excuse me, your process tells me that, by the way, process is not a documented procedure per se. That's going to be up to you. But you have a process, you have a way of doing things, and it says we're going to put this label on it because that's what our supplier had, and it means this, cool. Even though that's not what it says, if everybody in the company understands that that's what it means, that's great, okay? Obviously it's better to be less ambiguous, but it's up to you to define your process. The last bullet here talks about uncalibrated versus failed calibration. If I have a tool that comes back as bad, do I really want to put a for reference only kind of sticker on it? That's where we probably want something else to call it a non-conforming tool, whether it's a non-conformity report from our system, whether it's this failed calibration, do not use, something that's way more clear of the status of that tool. Because again, going back to the requirement from 715, it says, oh, sorry, click the wrong one here. Identified in order to determine its status. So we probably need to be thinking about what we can label it as or how we should be labeling it so that it doesn't create that ambiguity. Okay? The next slide, I have talks about expired. Now, we've already established that Don's weird and he doesn't like to drink milk that shows the day of or the day before. Some of you choose to drink milk that may be expired, and that's your prerogative. But when it comes to calibration, expired is expired. We've got a date on the tool for a reason. That's the date at which it's magically no longer able to be used. We're going to say that it's probably not bad. We're going to hope that it's not bad because then we have to go through that out of tolerance loop, right? But we can't say close enough when it comes to these tools. We've got a process for identifying that expiration date for a reason. We want to ensure that we're adhering to that procedurally, process-wise, creating the culture that if I have a tool that's coming due or due, it's okay to use. But if it's past due, it needs to be kicked back. We established earlier that we're a little more diligent when it comes to medication, even though it's good for decades in a lot of cases. But for the tools, we probably want to adhere more to that side than we do what we do on that food stuff that we're putting in our body. The expiry date on the certificate. I'm going to throw some commentary in here as well. Personally, not a huge fan of expiry dates on certificates. The reason why is the calibration house or whomever is doing that effort is going to establish the interval from the date that they did their certification event. And what we don't know is the conditions for handling, the conditions for storage, or the timeline associated with storage. So it can easily have been stored improperly. It may have been stored for a period of time where it wasn't used, and it could have exceeded that expiration date in storage without having any handling. Likewise, a tool that's still well within the expiration date may have been mishandled, and it's not reading correctly, but that date's given us a false sense of security because it hasn't been reached yet. So why I bring that up with a certificate is the certificate only defines based on an interval prescribed. It doesn't take into account other conditions. And you as a company can absolutely adjust that expiration date for your business needs with some data. I mean, we can't just say we think it'll be okay, but if we've got years of history to show that this tool's never wandered, that it's used in a controlled laboratory, and that there's no risk to this being dropped or mishandled, it makes sense to push that out a little bit versus a pin gauge that's used on the line every day. It's on a desk that's 10 inches long, so it's pretty there's a significant possibility that's rolled off the desk on multiple occasions, there's risk, and that's what we need to address as a company. Okay. So with that, we're going to get into some questions, and I see a whole bunch that have populated. That's excellent. We'll go through those as much as we can. Before I get into that, I want to show you just a couple of slides. We'll put our contact information up there so you can email us directly if you have more questions, and I'll afford my colleagues, Mike and Marty, the opportunity to answer some questions if they want, or to just chime in on anything that they'd like to offer. Marty, do you have anything to add real quick?
No, sorry, Don, I don't. Thank you.
Awesome. Mike, are you on?
I don't know if you can hear me.
We can hear you just fine.
Yeah, I just got on. No, I don't have anything to add. I thought it was very well done, as usual.
Excellent. Okay, so a couple NSF resources I wanted to share with you. On our website, a couple ways to get there. You can either remember this lengthy link, or you can go to our homepage, nsf.org, and then click on the Services tab that's right here. There's a drop down in there. You could select Aerospace, and that's what's going to pop up on this screen here. When you get to that page, you can click on this Aerospace Webinars section down here, and it'll bring up our newsroom that has 20-ish webinars so far, and this one will be posted into that section within a couple of days as well. Okay, so lots of good information on there. Feel free to go grab anything you want from there. They're all available. And then the other source of information that I pulled from was the IAQG's resources. So that'll be on the IAQG, the International Aerospace Quality Group's homepage. A couple of really cool resources here. One is the Supply Chain Management Handbook. Huge collection of white papers talking about every facet of manufacturing, of the soft processes, of the engineering processes. Lots of great information in there. If you ever have a question, go look it up in that system. Of course, you can email us, and we'll probably find it in there as well. But a lot of the information that I pull for these webinars is going to come directly out of that Supply Chain Management Handbook. The other source that I'll point you to is through these standard questions or the deployment materials. Both of them really take you to the same place. This one goes directly to the 9100 section. This one takes you to a matrix where you can select 9100, 9120, 9110, and some of the other AS standards like the 9102. But from that 9100 page, you can find that clarifications table, and that's where those IAQG clarifications are defined, as well as a great resource, one that gets grossly underutilized in the evaluation guidance material. It's a tool for third-party auditors to demystify, to decode the standard into more layman's terms, and to offer some examples of objective evidence that we might be or should be looking for. So as an internal auditor, maybe you don't necessarily understand what the section of the standard talks to. This is a great resource for you to go pull and try to understand a little bit better what it's talking about. So with that, I'll throw contact information up. If you want to jump off, feel free. If you have any questions, feel free to email us. Otherwise, we're going to just go through the list of questions and try to answer some of those as we chat. Okay? So first question, what about customer supplied check fixtures such as go, no-goes? I think we answered that one for the most part. The standard's going to tell us from the IAQG side that we're still responsible for those customer supplied, customer owned fixtures. The customers very well could tell us no calibration required, or they may take that calibration effort on. but we're still using it to provide confidence in the measuring results. We want to have the comfort that it's good. Okay. Why is every year the standard for calibration intervals? That's an excellent question, and I'd say the answer is because that's the way we've always done it, as sad as that is. It really is, as we talked, a risk-based decision, and we should be using that risk-based thinking that the 9001-2015 introduced, because it's not a one-size-fits-all. Some of these tools don't make sense to do on an annual basis, and some of those tools may need to be more frequent. Some may need to be, stretched out significantly because they're not going to wander. It's going to be a business decision. As long as you have data to substantiate it, your auditor shouldn't give you any problem. If they do, that's what the appeals process is for. If you can demonstrate through objective evidence that you've made a conscious decision and you've analyze the risks and they don't exist, that's great. Now the caveat to that is if your customer or your customer's contract says thou shalt calibrate everything annually, your hands are tied, you have to do it. Okay? We got to adhere to our customer requirements regardless. Next question. Does the definition of calibration cover automatic calibration such as spectrometer that will adjust the curve to a standard? If it's an internal calibration or setup, personally, and I'll defer to Mike and Marty as well if they want to, I don't see those internal startup calibration type efforts as something that we need to track through the calibration system. I turn the machine on, it calibrates automatically. I'm good. As an auditor, I don't want to see that. I'm looking more for that periodic confirmation that the tool is good, whether it's defined on a monthly, quarterly, annually, or otherwise. If it's something that's being adjusted on the fly based on the ambient temperature, the ambient environment, it may point more to the validation of the equipment, and that could be or is most often outsourced as part of the preventive maintenance program, something that your outsourced provider is going to come in and execute on that annual maintenance, right? So, Mike, Marty, anything to add to that?
No, I think maybe as far as software part of it, if there's software involved with it, then that should be validated at the time of calibration as well, if it's on an annual basis or more frequent or less frequent basis. If there's any software involved with that, turn it on and it calibrates itself, then that should be validated.
Great point. Next question. Wouldn't we want to be able to determine the verification status of an item rather than the calibration status? And this is where I think the nomenclature, the vernacular gets probably a little sticky. What we're looking for is the status, and that status is going to be fit for purpose or not fit for purpose essentially. Whether it's been calibrated or verified or both is going to be dependent upon the method that's been defined. Now, oftentimes we tend to stick to the is it calibrated or is it not, and based on the ISO definitions, that's not necessarily what we're after, right? What we're looking for is it fit for use? Is it capable of doing the measurement or the analysis that it's been selected to do? And how do we know that at the point of use? As far as verification status or calibration status, it's going to be a tool-to-tool, a business-to-business type decision. And if you would like more information surrounding that, or you have a particular use case that you're thinking about, that's where I'm on the screen right now. Reach out. We'd love to chat about those specific cases. Next question, do tape measures need to be calibrated when they are only used to verify the length of certain bar stocks when received from the supplier? I think we all have had findings issued on the tape measures not being used for final acceptance. I don't think we have a more controversial question in the presentation, And this is one that I'm sure Mike and Marty are giggling about as they're sitting on mute here. The answer is it depends. It really does depend on the nature of the work, the type of inspection that's been prescribed. If we're simply looking at the material to ensure that we didn't get shorted by the supplier, Don's opinion, no, I don't need a calibration. If I am a distributor and my customer's requirement is that it needs to be a 144-inch bar, and it's coming in and I'm going to confirm it at that point to ensure that it's a 144-inch bar and it's never going to be inspected again, I probably want to have some way of verifying my tape measure. Now, do tape measures go bad? No. I mean, you're going to see creases. You're going to see that they don't retract into the body, that the tab's broken off, whatever it might be. So I don't know that a daily use or daily verification check is necessary. Maybe it's just a one and done when it's first introduced and then when it's at the end of life. But some companies may choose to do it more frequently because of the volume of product that they handle or the environment that it's handled in. Ultimately, it's going to come down to your decision and the risk that that decision or the failure to make that decision presents to your product, your customer, to your business. Mike, Marty, anything to add to that one?
Just real quick, your point about the environment is absolutely correct. If it's bar stock and you're in a cutting tool environment or a screw machine environment, may be harsh on the paint that's on the tape measure. So maybe the numbers go away and you can't use it anymore. So periodically evaluating the fitness for use is good. And even taking your data that you've got, look back. How often have you had to replace these things because they were broken or couldn't be read anymore, or things like that, and establish a routine for just at least verifying that they're fit for use.
And Marty's point is great. It's not that the lines are going to magically move. It's that the lines will be invisible. They'll be gone from the environment that they're being used in. So that verification effort may not be taking a calibrated instrument. It may be that visual inspection that he was talking about. Okay, next question. Can gauge blocks and pins be labeled calibrate before each use where the machinist measure each block or pin using a calibrated measuring device capable of measuring to the range required? Ms. Jane, I believe, well, first off, it's good to hear from you, but the answer I believe we've already provided. If that's not the case, let me know. I'll chat with you by email. Next is please define why one would prefer to use an accredited calibration lab. What does the accreditation provide that is worth it? Customer requirements are probably the largest, or industry requirements are the largest reasons that you would choose that accredited lab. The other reason I would offer is an accredited lab has demonstrated to somebody that they're capable of following those methods. Your certificate for ISO for AS is accredited because NSF is beat up by the accreditation partners to ensure that our processes are robust, that our auditors are executing the requirements. And I shouldn't say beat up, I say that jovially, but it's no different than the 17025 type accreditation or the A2LA type accreditations. They're scrutinized to ensure that their processes are sound, that the methods are in accordance with the requirements for those types of environments, for those tools, etc. And now you have better confidence or more confidence in the output of their process based on that. It should afford you the confidence in the results, more so. Do you have to, some industries are going to require that your labs be accredited. Some customers may require that. You got to read the fine print in your contracts, okay? Do you have to calibrate a tool that has been calibrated and stored in a controlled environment but never used? This is where I threw in that certificate piece, the expiration date on the certificate. If your certificate, your calibration register says this tool expires on December 1st, even though it hasn't been touched since January when it was put back on the shelf, yeah, you've got to follow your process. probably want to rethink your process. If there's no risk of that tool wandering, if there's no risk of that tool being invalidated, it's still fit for purpose, maybe our process is such that it allows us to start the clock from the day that it's introduced into the system or introduced into the manufacturing environment. It's really going to be dependent upon your process and your situation, your interested parties' requirements. Do you have to calibrate a tool that has been calibrated and stored? We already did that one, my apologies. Do we have to include measurement tools, mics, calipers, etc. used in our tool room if we use first piece to verify all tooling prior to running production? This is probably one I didn't articulate well enough. What the standard tells us is that we're going to ensure fit for use on tools used for monitoring and measurement. The standard also tells us that we're going to define where and when monitoring and measurement is going to take place in our production activity or our product realization processes. So if we've defined an inspection point, whether it's in process, whether it's a first article, whether it's a final QA inspection, we want to have confidence in the results. We want to use those calibrated or verified tools to perform it. And let me say it more poignantly, those tools need to be calibrated or verified. We need to have the confidence that those tools are reading appropriately, that they're capable, etc. So if we've got a defined inspection, we've got a defined test, we need to use calibrated or verified instruments to perform those tests or inspections.
Could I add something to that, Don?
Of course.
In a tool room environment, it would behoove you to have calibrated gauges that you can rely on, because tool steel and everything that goes into it, and the time and the effort with the resources that are highly skilled, only to find out that the tool was no good when you do your first article or make your first production piece, and then try to find out what the root cause of the failure was, is going to be excessively expensive compared to probably having the calibrated gauges.
That's a great point. The calibration of a gauge versus redoing a validation of that tooling is probably minuscule as far as leaning towards the side of calibrating and having confidence in our tool. So, excellent point. The next one, our auditor said we had to clearly and specifically define what verify before use means in order to use the term in our shop. Do the standards have a definition for this? I think we talked a little bit about the verify before use methodology. Again, the requirements are we demonstrate fit for purpose. We have that tie back to national or international standards. So if I've got that box of pin gauges, the micrometer next to it, I've got a log where I'm signing out the pins saying, use this micrometer. We need a process, not a documented procedure, but we need a process associated with how we do that. We can accomplish the execution of a process through training or through documented procedures or through other methods. That's going to be dependent upon the competence of your workforce, but we definitely need to have a process on how to handle those situations. We use a visual board that consists of automotive parts for a visual reference only for our shipping department. Do these need to be tracked and calibrated? So the visual board is meant to be a reference to show, this is what this part number looks like. I would assume. No, I don't believe there's a calibration effort for that. Marty, you can help me out if I'm not understanding the question. But we're going to calibrate devices or verify devices that are used for that monitoring and inspection activity. If it's a comparison type tool or optical comparator as an example, we definitely need the calibration or verification there. But if I have a known good sample hanging on the wall to show what a good part should look like, I don't see any calibration effort that's needed on that. but I'll say it depends on your business needs, your situation. You can absolutely do it. You define the methods, you retain the documented information, etc.
In those situations, it might be helpful as well to use some measurement system analysis technique. If it's an attribute gauge, to find out if the people who are closest to the process are going to consistently give the same type of result based on what they're measuring.
Great point. So the next question here, torque wrench is used to secure raw materials to machine features, no SOP or customer requirements. Do they need to be calibrated? I think we have talked about the calibration before use on the torque wrenches, but as far as what torque wrenches need to be calibrated, that's going to be dependent upon you. The reason I wanted to address this question is for attaching like a mounting plate or a fixture into a milling machine, right? We got this torque wrench that's going to help us ensure that our jaws or our fixture has been put onto the plate appropriately. And a lot of times I see torques associated with that so that the jaw doesn't have chatter, that the jaw doesn't move, and that we get a good foundation for where that part is going to mount into the machine. If we've defined the torque that needs to be tightened to, we'd want a calibrated or verified torque wrench to be able to demonstrate that it's met that torque requirement. If we're just saying, you know, this is the wrench we have available and we're going to torque it down, that's a different story. But if we call out a tolerance, we call out a minimum value associated with how a process is to be performed, that's where we tend to bridge the gap into a calibration or verification type environment. We're going to take one more question in the interest of time, and we'll answer the rest of these via email. So if we didn't get to your question, I do apologize for that. We're kind of running long, and I want to get everybody back to doing what they do. So the next question, last question here. Several years ago, attended a calibration seminar in Washington put on by NIST about calibrations. At the seminar, they commented that NIST does not promote or condone the use of traceability to NIST by the public. How do we reconcile that? As you saw from the standard doesn't say NIST. It says national or international standards. And really what the calibration house or the external provider needs to provide is some evidence that their processes are then traceable back to a standard that's more resolute, more finite than the standard, or excuse me, than the tool that they're calibrating, right? They've got that 10-to-1 ratio met. So if they can do that by a statement that says our tools are traceable to NIST, that's great. That's their process. If they say we do it in accordance with our procedure, and here's the serial number for the assets that were used to perform this calibration or verification effort, that's perfectly acceptable as well. As we saw in the IAQG clarification, they said there is no requirement, let me go back to that real quick, there is no requirement for, oops, wrong one, right, oops, wrong one again, third time's a charm. There is no requirement for the certificate to contain the traceability information for that national standard, right? We need to be able to show that it's done at this lab. We need to be able to show that it used these serial numbers, but we don't need to necessarily show the national measurement standards traceability information. So it doesn't have to go back to that NIST asset. We just need to be able to see the trace back to whatever that third party's process is. And that could just be, I've seen plenty of certs that say they don't have tools listed. They just say it's this certificate number, and if you want more, give us a call. That's perfectly fine because there's a linkage from that certificate back to their process, to their methodology, and to their records/retained documented information. So with that, unless Mike or Marty have anything else to add, we're going to part ways and say thank you once again for attending our webinar. Thank you for your continued support. And if you have any further questions, feel free to reach out to us via email. For those questions that we didn't get to, expect some emails in the next day or two surrounding a response to those, and we'd be happy to set up a time to give you a call and answer it more directly that way. So thank you very much, and have a wonderful day.